Welcome everyone to another episode, and this first off I wanted to start off with a unboxing. I think I know what I got. I'm pretty sure I know what I got. But we'll leave that surprise to you and me. And I'm using the larger uh, screen, so hopefully I don't scare anybody. So we'll see how that goes. I don't use it very often, and I think maybe this is the second time I tried it, so we'll see how it goes. And let me grab. Got this little box in here. Has a battery in it. So I'm pretty sure I know what this is. And we'll go ahead and let's see. Do I need to angle? See if I can do this without knocking it off the. Yeah, that's pretty good. Now you just see my beard. Alright. And if this is what I think it is, this means a lot more content in the future for all of you. And not necessarily live stream content. I don't know. Should I come down here and see what you guys got? Yep, it is what I thought it was. And there's an envelope. What is this? Oh, 64 gigabyte scan disk. That's true. It's a flash drive. I believe that's what those are called. Or a SIM card. No, it's not a SIM card. It's a memory stick. It's basically what it is. I got that upgrade. So what is it that you guys are maybe wondering? Well, it comes with a dual battery and charger. So, something electronic, obviously. And this is it. It is the GoPro Hero 8 cam. So, I can do some, well, this was really in preparation for, I really wanted to get into doing some Build It Now series because I have a lot of projects that there's no design. I just start doing them, like the flower bed or building a box for plants. The list goes on. In fact, I'm doing a custom build for 4 of my mining GPUs, and I'm actually converting a very old sewing cabinet, and I've got a lot of it done, but I'm thinking I might finish the build with this GoPro and take my hand at doing some editing and stuff like that. This is a pretty cool device. It is called a chesty, and what it allows you to do is mount the GoPro onto your chest for hands-free. So I'm really excited about trying that out. And then for long shots and stuff, like I plan on doing recording when I start the 10 by 20 shed. So this would be really handy to set up. I can do different shots between far and up close with the chesty. And then this is the media mod, and this helps. Let's see. Oh, it helped for if I showed you guys the picture. I probably should take it out of the package so you can see it better. But actually, you know what? I can do that real quick because the focus wasn't very good. And I'm getting a lot of glare on the light overhead. There it goes. That's a little bit better. So, very excited to play with it and test it out. This media mod, basically, you attach this to it, and it has an extra microphone and clips and all kinds of neat little things that just makes it easier to hold if you need to, stuff like that. So it's really neat. So I'm really excited about getting this going. And they packed a lot of stuff in this tiny box. I tell you what, that was crazy. So that's the big surprise. Let's see if I can put everything back. Not too bad. So I'll be looking forward to that pretty soon. Getting these going, getting some extra content on, some recorded stuff. Let's move this back into position here. And I think that's pretty good. And if you'll see me looking over to the right, It's because I'm looking at I have dual screen set up, and I always make sure I have all my stuff that I track to my right. So I probably should like switch the screens around or something so I'm always looking dead on when I'm checking something. But then if I'm working, then I'm going to be over here all the time. So that might be a little more annoying. I don't know. All right, so let's switch over to that view. It's a little bit less scary. And let's see what we got here. Last episode, we did a lot of modification to the framework that carries the GPUs. And I'm still toying with the idea of putting some kind of like drain pipe. Well, not drain pipe. Let me see if I can pull it up. Let's see if I can picture. Yeah, that kind of something like this. Let me grab that and throw that over here. Kind of doing something like this in oh, where is it? There it is. In this area here, probably more of like a swirled pattern, but I'm not sure if that's what I really want to do. I mean, I know I included some holes in the bottom there for airflow as well, and I really wanted to force the air through and around because these fans will be running and pulling in air, and then this will be pulling air throughout. So my goal was to more so make sure that I'm having the airflow coming out over and around and through this way. If I do an upgrade on SolidWorks, I can actually do some flow analysis with yeah, I don't have that. Anyway, flow analysis, airflow, water flow, fluid flow, uh, all kinds of calculated dynamics and stuff like that. Um, and maybe that's something I can do in the future. Right now, I seriously can't afford it. So, I mean, that bumps a year's subscription to SolidWorks up by, I think, another $1,500 or something for the year. So, a little bit out of my price range right now. So, anyway, looking back, the other thing that we were looking for is more information regarding the motherboards. I stated last episode that I really wanted to make sure I had hole patterns for the three main size boards that are generally used for in computer cases. The one I will not be designing for, which based on how big this thing is, that I probably could, but we're going to focus on the three, and that's the ATX, the Micro ATX, and the Mini ITX. So from there, I did some research, and lo and behold, I was able to find some really good information out there. Hello. Okay, what is it doing? For some reason. These came in a two-dimensional AutoCAD drawing, a DXF format. It's an exportable format that SolidWorks can pick up and either make a part out of or make a drawing, basically, for you. These entities are selectable, and they do whatever they can to convert them into dynamic SolidWorks objects. But that's really not what we need for this application. I do like the keep out areas. Oh man, this is so weird. So it gives you, now if I recall, the keep out area, and then this dimension here is your height. Clearances for height. area B point, and I don't think that includes 7.6. Oh, well, 76.2 millimeters. That's 3 inches. That's very possibly the area where they're calling out for the CPU to go. It's very possible. But as you can see, they have dimensions that give me all the hole spacings for the ATX, and this website, they have the micro ATX and the mini ITX. Oh, that's a little bit zoomed out. So I was very excited to find those. All right, let's see here. I was alerted to a viewer comment. Paladin, hey, what's up? Will a micro be able to run 4 or more GPUs? If you use, well, it'll depend. Okay, that's actually a very good question. I'm just starting to learn about this and research it. There are motherboards out there that will have 2 to 3 PCIe slots. Generally, one is a -16, which is the most common one that you will find for plugging in your graphics cards. And then they have a PCIe-8, and those are smaller. You know what? Let me pull that up real quick so I can show. Mini ITX. Let's see. Let me just pull one up and see if it has a good. Yeah, here we go. So, let's see. If I do, there we go. If I show you this area, see, this is a PCI Express or PCIe times 16. Now I called this a times 8, but it looks like it's a times 1. I get those confused every once in a while. But like this one has one full 16 and a times 1. So what you can get is what's called a 1-to-4 PCIe adapter. And if your chipset that's tied to the motherboard and to your PCIe slots, if you have enough lanes and your CPU can process those lanes, then you can support up to X amount of graphics card because they only use a certain amount of lanes. At least that's my understanding as of 6:13 p.m. 9/14/2021. If anybody has any other information on that, or I'm completely off my rocker, let me know. But my understanding is that it's tied into your chipset. Like this one has an Intel H310, and then whatever CPU that you put in there, it has to be able to utilize and recognize whatever PCIe lanes are for this chipset. So there's a lot of communication between the motherboard, the chipset, and the PCIe Express slots. I have not accounted for the height of the splitter yet. That is something that I can add to this design, since it's basically I changed the focus from purely just what I had on hand to giving a little bit more versatility to the design to include ATX, micro ATX, and then mini ITX. So that'll be one thing I will definitely do. I have one of those splitters. I can get the dimensions off of there and throw it on the board. And that way I can do that. And yes, you are correct. They are pretty tall. And in fact, I actually modeled just a block to kind of give an idea of the size of some of the taller coolers, fan coolers that come with like the AMD and Intel processors when you buy them with the cooling fan. Now I know they have them that are much larger than this, but you know, I want to be practical. I don't want somebody putting in a 6 or 10 inch damn cooler when for mining you don't need that. You know, your cooling needs to be focused on your GPUs because your CPU is not going to do a lot of work. Now for the PCIe four-way splitter, the 1 to 4 splitter, I will be throwing that in. And if I have enough time, I'll actually do that tonight. But for now, my main focus was getting these holes in where I need to. Let's see, let's start with the ATX since that's when I got modeled. And with this information, I can actually verify the sizes that I got in there. And I actually have this in PDF format, I believe. So I might switch over to that. That way I'm not flipping back between screens in this area here. Just to make it easier on me because SolidWorks does not like it when you flip a lot. So let me pull the PDF up. Let's see, cutouts, that's the boards. And that opens up on that's fine. Let's make sure it has that same information here real quick. Bear with me 1 second, ladies and gentlemen. Love the design. Great job, Paladin says. Thank you. I appreciate that. This is... It's taken quite a many hours to get to the point where I am right now, so... yeah, it's definitely been fun. That I can close out. Whoops, hello. This I can close out. And this was actually the resource that I found. How to design custom enclosures for motherboard-based systems. If we want, after I get done, I will modify the title, the information, and make sure I provide a link for this. So that anybody else can use it for whatever else they want to do. I worked for a company that we actually got some quotes for them for some custom designs for enclosure cases that I designed for one of the companies I worked for a while back ago, a couple years ago. Spent 10 years with them as Elecsys Corporation. So I'm very familiar with the work. I just didn't know that they had this as one of their resources in their, I think it's in their technical papers. But it's a very nice information. I was very happy that I got it. And I also bookmarked it so I can have it for later. Alright, so without further ado, I grabbed that information. Let me verify that the information that I need is on there. Let's see. That's for the ITX. I need the ATX first. There we go. That's what I need. And I need to back that off a little bit on the Zoom. No. Oh my goodness, that's... Oh wow. Okay, this is trying to do different... Lord have mercy. I don't want to have to do this. Can I plus and minus this thing? Ah, yes I can. I just want to get that in the main focus. Oh my gosh. This is not like SolidWorks panning and zooming around. Okay, I think I got the dimensions that I needed. Alright, let me go ahead and close these out because I only brought those up just for say, hey, this is what I was looking forward to grabbing last night and I got it. So, very excited about that. And I'm going to shrink this up a little bit so I can keep anybody that wants to comment in here. And if I don't comment right away, I'm not ignoring you. I just Got a lot of windows up. I need about 3 or 4 more monitors. Let's shrink that over so I can see more of. There we go. That's what Okay, I think I got all the dimensions that I need. Yep, they dimension this exactly like I do. Alright, so let's go ahead and open my ATX board, and first I think what I'm going to do is change the name of this to motherboard. Rename part motherboard. Rename, and I'm going to save that. We'll save that. Just go. Did it get it? Yep, it did. Okay. And then I can go through here and do. Now, let's rename this ATX. Alright, and we'll go back, and I think what I'm going to do is suppress this feature for now because I don't have the dimensions for where, in general, the CPU is for each of those boards. And I don't know if that is a industry standard of where they place certain things. I know like your input-output is in pretty much along one of the edges, depending on the orientation of how you put it in your case. So let's go ahead and grab this, and I'll verify we have a, yes, 9.6 by 12. And then I'll probably, oh, they do have these in, okay, alright, that's good. And these are 0.15 inches in diameter, so slip fit for a 632 screw. You know what I think I'm actually going to do? I'm going to use my hole feature here. And it'll just be a through hole. And that should be, if I do a screw clearances, yes. And I want it to be a number 6. And if I look at the sizing, yeah, 0.1495, that's 0.15. So in condition through all, that's exactly what I want. And let's make sure. Oh, I don't know what it was doing there. Let's see. I was going to make sure that we had the right orientation here. Actually, we don't. You know what? Let me exit out of that and redo it because I got to make sure. I want the top. Alright, so we're going to change this to match my drawing. So this is going to be 12. And this is going to be 9.6. There we go. That way it's all facing the same way. I use the same edge that they do. And everything is smashing and wonderful. Alright, so let's go back to our features and grab our holes. Number 6. Yep. And our position, and it's going to be on this plane. So what I'll do is I'll just go through and smack some down. And then I'll throw the dimensions later. About there. Sometimes when I eyeball, I actually do get really freaking close. Sometimes. Those should be in line with that one. Alright, now we'll go through and put some lines in here. And then you'll see why I do this. Kind of a cheat for for doing groupings of holes that actually line up and work together with each other. Looks like a gridded mess, but it's fine. So I'm going to dimension the lines first, and then I'll snap all of the holes where they're supposed to go. Well, let's grab the dimension first. And they reference this as 0, 0, the bottom board edge. So we've got the first set of holes is 0.4 inches up. Now, do they go? The next one is 1.3. Oh, why did it do that? Okay, okay. 0.4. Let's try this again. There we go. 1.30. This, I think it said 6. Why is it not giving me the... What is it doing? It's carrying that as a base. Okay, that's interesting. 6.5 for this one. That's weird. I've never seen it do that before. And then 9.350 for that one. And then left to right, here to here, we have 0.65. So yeah, that was 0.63. And then to here. Let's zoom out a little bit so I can put these where I want them. Let's see. From there. Oh, I missed a line. Okay, well, I'll come back and do that in a minute. 5.55. And then this one here is 11.75. And then I need to add one more line for this oddball guy. And that is... should go right in there. I'll reorganize those dimensions here in a second. Let's see, that one is 3.75. Let's pull those down so I can see them. So, this one gets tied here. This one gets tied here. That one gets tied here. And this one is my oddball, so this one gets tied here. Okay, let's try that again. There we go, intersection. Let's see, that one gets tied to this one and this one. Okay, oh, okay, that already grabbed it earlier. Okay, well, that's good. That one goes to here and here. That one goes. Now, I could have just as easily done the holes, or the lines first and then the holes. But this is fine. Okay, so I'm going to verify. I've got 4, 2, 1, 3. Yep. Alright. Perfect. Alright, now we're going to make a configuration. And that one's going to be micro ATX. And make that easier. This goes away. And this gets modified. So let me find that one. Micro ATX. Okay, how do I control minus to zoom out a little bit? This one has a lot of extra dimensions in it and stuff, so whoa, hello. Okay, hole patterns are left, right, up, and down. Okay. Oh, excuse me. Alright, so we're going to double click, and for this configuration, that's going to change. I think it's 9.6 by 9.6, so that one actually doesn't change. This one does, though. This configuration, 9.60. Alright. And then we do the same thing with the holes, since we already got the, it remembers the last information you put in for your hole positions, or your hole call out information, so as far as your type goes. Alright, put this there. Alright, so we're going to go here, here, here. We've got, looks like, there, there, there. One that's over here somewhere in La La Land. Alright. To our lines. Should be all of these. All of those line up together. All of these line up together. Let's see. These three line up. And then I've got these two that line up, and then that one is all in its lonesome. So I can just do that one by itself. We'll keep it the same. We'll make lines for everything. Alright. Now dimension. From here to here we have probably the same. 0.4? Yes. 0.40. That did not attach to it, so I'll have to make sure that does that. And then this one, again, numbers your up and down, but not your left and right. 1.3 should be. And then this one, now it doesn't. Okay, this is strange. 6.5. And those didn't stay with it. That's interesting. And then that one should be, yes, 9.35. And then left to right, we've got from here to, seriously? Yeah, we put them down here last time. We'll do the same thing. 0.55. Whoops. Oh my goodness. First one is 0.55. I don't know why it does this. It's so weird. It decides whether it wants to. Get it. Alright, this one is 0.35. This one will be 3.150. 1.35, 3.15, and then 9.35 on the out. Okay, now let's make sure all of our holes are where they need to be. So we have this one goes to here. This one goes to here. This intersection. This one goes to this one. That one up there is fine. And this one should be right on the money. Okay. So verify we got 3, 1, 2, 1, 2. Okay, good. And we'll do another configuration. Actually, let's verify that we did this right. Boom. Boom. That's weird they put an extra hole there. I don't recall seeing that before. Hope this is right and up to date. Alright. Now we'll do a mini ITX. Kill this. Oops. Hello. We'll edit this and let me scroll to that one on my PDF over here. Bounce that out just a little bit. That's the call out for that. Okay. 0.5. All right. So this is 6.5 by 6.693. Interesting. All right, double click that with this configuration, and that is, oh no, it's 6.693. 693. This configuration is 6.6. Oh, hello, Kitty. Thank you for trying to. That is tiny. Oh my goodness. Now, this one only has 4 holes, so that should make this go by pretty quick. Oh, features. And verify that. One here. So this one about here, there, there, and there. All right, let's do some dimensions. Oh, I forgot one line. Crap. Did that the last 2 times. 4. And then we got that one's a 1.30, so that's the same. That one should be, I believe, 6.5. Yep. And then we go from here to here. That is 0.25 for that. And then 6.45 on the odd. Alright, lock them in place. Hello? There we go. Didn't want to recognize it at first. Alright, done. So now what we have here is I've got every single hole pattern for mounting. Now the reason I did that, if you missed last episode, was for the standoff stacking for mounting other equipment when space is limited. So what we can do here, alright, let's see what that's about. Shit, I don't know why this is having issues. I don't know why it does this. This is so dumb. Oh, because I changed the orientation of the way it was put in there. That's why. Okay, so so what we'll have to do is fix that by rearranging this shit. Alright, we'll delete those. I'm not sure what these are for. It's gotta be for a different... Oh, that's right. Alright, so let's get this back to the correct orientation. What is this? That's coincident to that. That's actually going to have to change as well. So let me... And this, I think this needs to go away because I think I'm going to have to redo some of this information here. So let's spin that like that. And we'll get this orientation. Oof. Do I have... Yeah, it's 45 off. So... could have sworn I had an extra little plane in here somewhere. It's not it. Nope. Nope. There we go. I believe that's the one I want. Can I... Oh, shit. Come on. And I want that parallel with it. There we go. And that's what I need for that. Oh. Now, what I'm going to have to do then from here is basically create a, push a template through to this piece actually, you know what? Yeah, I believe that my common hole is the 1.3.4 and what is that off? 0.25. I think those are my. Oh, and the 6.5. Those should all be pretty much the same spot on every single board in relation to where it's at. So let's get this locked in. I have it locked in as far as the parallel on it. So let's go ahead and get this. And I think we did, let's go ahead and do 1.5 because that's where I'm at now. And my goal was to create a mount where this can set up on top of here, on top of the printed circuit board, or motherboard rather. So I'm going to have to figure out where my common, so this may have to rotate 180 degrees because I believe this, and this are all common to all three boards, or all three boards. So depending on the board selection and what's going to be used, most likely it'll be a micro ATX and an ATX, because I am not 100% sure that the mini ITX will support that many, will support 6 CPUs. I think it'll depend on the chipset, PCIe lane, and the CPU, so that it can recognize and utilize all of those. So let's get those templates down, and basically what that means I get to do is go through and do those holes again, but on this piece, and then we can finish tying everything together here. Ooh, let's see. This is my. I'm gonna extend this out here so that I can see it all the way through. That's down the middle. And I want the, let's see here, my first one, given where I'm putting this, I don't have a left and right yet, but I'm going to push it as far out as I can. Let's see, I probably could. You know what, let's do, since I got this locked in place and I like that spacing, because I think I'm going to have that, yeah, this side will be where all the cables come out, so I think I'm going to need this room. Nope, I want this one. We'll make that 1.875. Oh. That was weird. It looked like it moved that other. Oh shit, that's not locked in place. Damn it. Okay, I thought that was locked in place. That's right, I didn't put the holes in here to lock that in place yet. Alright, well, we'll do that based off of this information. And actually, that looks like a pretty good, just eyeballing, that looks like a pretty good spot there. And then what I'll have to do is bring through the larger ATX power supply units to make sure all that works in there as well. Alright, so let's do this. Gotta keep track of my time too. Yep, after I get done with this, that should be a good time for a little break. And then I can get back to it. So yeah, looking at this, this might be all we have time for tonight. We'll have to see. What size holes did I use on this piece? I don't remember. I think I did a clearance for... Oh, number 8. So an 832. So I probably should do a PEM insert. And that would be ideal because they can press fit those in. And we use them all the time. They're actually really great for doing standoffs, pressed in standoffs. And based on that information, I think a 1/4 of an inch standoff, if I do a press fit, I used to have all these. Let's see here. There was FH4ZI or FH4 4632-4. Dash 4, I believe, is the 16th, so 4/16, that is a 1/4 of an inch, which I believe is what I just said. So, PEM engineering. Oh, it's PEM engineering. Yeah, PEM. Wow, that's hard to say. Fasteners. Except the cookies. Me like cookie. Yes. Let's see, for sheet metal. And I'm looking for the I definitely want the through hole. Those are easier to size as far as your depth. Because then you have to have the right, you have to take into account the board thickness and the space that you're giving from underneath where it mounts or where it's pressed into the sheet metal to the bottom of the board. Whereas if it's through hole, if you accidentally order it a little bit too thick or too long, your screw, as long as it's not like and more than a 1/4 inch too long, then you're good. Or else it'll crash into the plate, and we don't want that. All right, so let's do through hole. Let's do all right, let's look at the SOAs. Let's see. Standoff, through hole, threaded. That's what I want. Standard. And I need 632. Oh, no. Ah, there they are. 632. And let's see. I definitely want 0.62 for the board. And then at least that in engagement. So I think I'm going to go with if I do a 1/4 inch, I'm going 1/4 inch up off the board. Oh wait, no, that's not what I want. That's not shit. That's not what I meant to do. This is asking my length, and I wanted a 1/4 inch, so that's right. So, oh, that's 8. So dash 4 is an 1/8 of an inch up off the. That's weird. A 632-4. That should only be an 1/8 off. No, that's a 1/4. 4/16 is a 1/4. Duh. Oh my god. But they call them out differently here. So what are they recommending? Oh, a PEM stud. Oh. Oh, and then they're doing a threaded post on top of that, and then a screw on top. Nah. Nah. That's not how you want to do it. Do it this way. Press fit. Don't have to worry about it. Let's see. Aluminum, because that's what I'm using as aluminum sheets. Zinc plated? Nah. Nah. Standard finish is fine. And sheet size is 0.281. I believe this one is fine. I can't remember. I think this has a thicker wall don't remember. Oh, this one's a little bit taller too. Okay, this is the one I want. Step file, or do I want... I think I like IGES better. Download. See if this works. This field is required. Okay. Wow, I can't spell. And there we have it. Show in folder. We're going to grab that and put it in our this folder, and I'm going to just put it in here for components. And then I'll probably move this around if I can start getting a collection, like a library. And I utilize these a lot in other places. This is going to be engineering. And this is the SO, shit, what is it again? SOA series, okay. SOA. And paste it in there. And I'm going to get rid of all this information here. And there. Then, if I remember right, I can just drag and drop that bad boy right into SolidWorks, into a new part file. Or I can just drag and drop it into anything, and it'll just create a new part file for me. No. Do not want a derived part. I want it. Boom. No, I don't want to do that. Hello, where'd it go? There we go. And, yep, that's fine there. Boom. What's this? Yeah, that's fine, I guess. I don't... It used to not do that, where it would maintain the link to the IGES file, because, I mean, I don't plan on ever modifying it, but that just reminds me that I can't delete that IGES file because it's dynamically linked to it, in case if I want to modify this at all. Alright, so my hole pattern for the 632 will be 0.213, or my hole size, and I'll have to match up the hole pattern. So let's do it this way. Let's go to this. I'm going to grab that and that, isolate it. That way it's easier to work on. And we're going to go ahead and edit that part. And since I've got this pretty much locked in where I want it, I will be able to make holes and utilize this information for my hole pattern where I need it to go. If I can select the right damn button here. Alright, so, you know, they had... Aha! There we go. I knew they had the PEMs in here. Let's see. And I think the blind will work just as well as the SO. Hole specifications. I need, yep, 0.213. Oh, that's so nice. Alright, let's do it. That's going to be on this here. So we're going to go there. There. And then what I'll do is when I bring in the other boards, come on now. We'll have to make sure that these hole placements don't interfere with the board when I put the other holes, if there's any that are off of this, if I put them somewhere else, because this will maintain the same DLC. Very nice, very easy to do. And actually I can do that the same thing with the other component, and I'll probably do that here in a second. Now what we want to do is, no, motherboard, I want to change that to, whoops, hello, micro ATX. That's fine. We'll deal with that in a second. And then let's see how many of these actually mount up. So it looks like just those ones, and I'll have to account for these two as well. I don't remember seeing that on my micro. Alright, we'll put them in there. Where is... I need... Oh, that's right. Okay. Let's... Okay, something's goofy here. I may have to... Let me bring that open and see why it's saying that. What's it doing? Well, I guess... Yeah, it's the only thing I don't like about the dynamically linking it, because it... Since I changed the... the board, the configuration, it's saying, hey, all of these holes are gone because it's a different sketch, so it's fine. Basically what I'm gonna do, I don't care, just go away. I said go away, I don't care. That's fine. What we'll do is we'll go in here and edit the sketch. And actually, nope, that's, oh, no, that will work. Crap. Edit that sketch, and I can add I can add two more, and then those will automatically come through, and then we'll modify, where to go, that is here, change that to the mini, and those are in place. Perfect. That's perfect. That is exactly what I want. Now what I'll do to get rid of this error is I'll go back through and dimension all those. And then what I'll have to do anyway is make an assembly with those PEMs in there, and then rebuild it with the assembly in place of that component, the single component, because now it's an assembly. So for now, I'm going to leave... Oops, that's not what I want. Let me change... Good Lord have mercy. Oh my God, why is it doing this? Jeez. Go back to the ATX. Stop it. I don't care. But you got all these holes and I don't see them. Yeah. Alright, where are we at on time? Alright, so we're going to break the link. Okay. By getting... Oh! Oops, that's not what I meant to do. I just want that gone. And then I'll dimension those. Now, this is going to be the fun part. I got to dimension these off of no edges. So it'll pretty much be like a theoretical edge. Let's see what's okay. That still shouldn't be giving me this that freak out. I don't know why it's doing that. I don't understand. Maybe once I get the dimensions going, it'll be fine. Alright, so let's see here. How can I do this? Because I don't really have a datum or a point of reference for it to say, this is the corner 0, 0 that I want your edge to be. So what it'll have to do is go off of a imaginary center line. And that's, I think, what I'll have to do. So we'll go from here to here. And then left to right. Eh, what? Why is it? I don't care anymore. So this is going to be a big old hairy mess. But this is how I'm just going to have to do it. Each one of these gets dimension. I don't care where it's at because that's where I need it to be. Get all of these up and down. It's going to be a mess. That's why I'm not worried about it right now. Go there. Oh, whoops. Yep. There. There's fine. Yeah, this is a very screwy way to do this, but I'm not building a very nice little thing here. So as long as there's a datum and you dimension to that, they can find it. Okay, I got all the ups and downs, so I need left to right. So we'll go from here and start at a far point. And I'll go ahead and just bring that up here. What? Okay, why? Why? What is it doing here? For fuck's sake. Oh my god. That freaked me. Okay. Good grief. They have to make it so god dang complicated. Oh, nope, 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 nope. That's not what I want. Get rid of that. Do that again. Do not want. There, that's what I want. This one. This one. It's fine. Oops, come on. So doing it this way saves me a lot of time. Hopefully, as long as it behaves itself. A lot of time and energy doing this, finding the X and Y from an imaginary point and then typing all this information in. Okay, I think I got them all. Alright, let's do this and see what it does. Perfect. That's exactly what I wanted it to do. Let's save that real quick. And then need to make an assembly from this part. And What the hell? It generally asks me to drop that shit in. Okay, that was weird. Let's verify that I don't have anything else going on goofy with it. Errors went away because now it won't matter what motherboard I have. Oh, the holes remain. And it doesn't throw up any errors because all the holes are tied to... Oh, did I forget those? Why are they over there? Okay, what the hell just happened here? Okay, this don't make any sense. I must have hit something by accident. Jesus. Alright, let's look at this again. Got something goofy going on here. Let's see here. Because those are not where they need to be. Did I goof that up? Alright, so the difference between those and those is... Oh, I want a dimension. I want center to center. Center dist. There it is. So it needs to move that way. Ooh, that's going to be tricky. Let's do this. We'll edit that part. And we'll edit this. Yeah, I don't know why those got thrown away like that. Yeah, there should be no relations. Okay, let's just delete those then, and we'll put new ones in. Oh my god, that's to be difficult. Okay, and then I'm going to kill those. Then I'll dimension it. That should work. Let's save all that good stuff. And let's look at, oops, bring in that other motherboard. Oh, those are still there. Everything else is aligned. Okay. I don't know. Sometimes it acts so goofy. Oh, what's going on here? Why did this not change? Or why? Oh, God. Why is this moved? Oh, fuck. I know what happened. It's because it's not locked down for the other. I have to lock these down first. God damn it. So all of those holes are wrong. That's got to come over here. Yeah, I don't know. This doesn't make sense. Why did it move? It should have locked it when I locked it in place. All right, let's try this again. Let's do 0.250. All right, so everything I just did, I'm gonna have to redo because I forgot to lock that in place. Now it's locked. Excuse me, sorry about that. All right, so yeah. Jesus, I can't believe this. Yeah, every single one of those damn things is gonna have to be moved again. All right, let's do this. Let me get this isolated. Whoops. There we go. Get that isolated, and then, is that right? Do I want that close to that edge? That's the other thing I can double check too. Let me bring up the where is the, there we go. No, I don't want to see that. I want to see, there we go, the 500. Actually, no, I wanted the mounting bracket for it. This can go back away. Actually, yeah, that's fine. That looks fine. That way I can do this one at the same, or do this one also, because I use those 832 on that. And I should do a PIM nut for the bottom side of that. Because I could do, like, try and do a threaded. I don't know, I got that pretty thick. What is that thickness there? Let's verify this. Yeah, I did a pretty stout plate for that. 1/8 of an inch. That's 1/8 of an inch of thread. I could just thread. Make that a threaded hole. PIM nut would be stronger though. Since I'm using PIMs, I'll just use PIMs on that as well. That way you guys can see how that works. Yeah, we'll do it that way. Alright. Time for a small break, and we'll be right back. And we'll fix our little mistake here, and we'll add some other stuff, and we'll keep rocking with it. Alright, we'll be right back in a few minutes. Alright, and we're back. Get some stuff here. Alright, here we go. Alright, let's fix my little mistake here. And it's cooled off a little bit. So I've got to reach over and pull this fan off me a little bit. It's chilling me to the bone. Scrap that over. There we go. Alright. Now, let's edit the part. Edit that. Oh, no, that's no. That's not, that's the wrong sketch. There we go. That's a lot of stuff to remove. Okay. Let's get rid of all these dimensions. I'm going to have to redo them. Oh, that's so annoying. I apologize for this. It's kind of dumb. Oh, so I gotta delete all those too. Okay, well, let's just do it. There we go. Let's go back and fix this. Come on, I want the center. Falling off my mouse pad here. Oop, there we go. That one. Ah, come on. This one. Then we go back through and delete all these. Dimension them, and then we'll switch. Mention those, and then we'll switch to the other one and dimension all those. Come on, grab it. Try and do this a little neater here. I don't know why I'm having trouble with my throat. It's all the up and downs. Now we do left to right. Okay, that should be all of those. And now we swap motherboards and do the same thing here since I only needed to add these two to this. That should make it relatively easy. Oh, I picked the wrong sketch again. This one. And boom. And there. Dimension. That's what? There we go. All right, now we're rocking and rolling. Okay, that didn't take too long. Exit isolate. Now that board's in place. It's not going to move. Go back to the ATX. Boom. Alright, and that also means I can get rid of this component here. That is in the, it's in the shell assembly. Open that up and get rid of that standoff because I'm using PEM inserts. Or PEM standoffs, good lord. Alright, so now we go, let's go ahead and save this bad boy, and let me go ahead and do this one because this won't be too hard either. Oh, I want to fracking isolate that. Isolate. Then we'll go through here, and since, well, this will be common on. Oh, yeah, I've got to check the mount for the big boy when I put it in there too. I forgot how I did that. Yeah, I'll have to look at that as well. That'll be an interesting. That'll be interesting. Okay, so let's do. We're gonna edit this part, and I need. Oops, the whole feature again. And this is gonna be an 832. And that needs to be a PEM nut. Aluminum. There we go. Self-clenching. Can't remember if this either the CLSS or the SS. I'll have to go revisit the website and see which one that is. That should be 213 as well. Oh, it's the same. Really? Oh, that's right. Yep, it is. Okay. Ignore me. There. Come on. There. And then if I move this in a different orientation, I'm going to leave these tied to this so that if I move this bracket to accommodate for the larger size ATX style PSUs, then this bracket will move with it as long as, or well, the holes will move with the bracket. So yeah, I'll leave that like that, and that should be good. Yeah. All right. Yeah, I just gotta put those PEM nuts in. Alright, so we got that one. We'll do that one first. And we'll fit that. Make assembly from part. There it is. Put that bad boy in. And then we want to insert the SOA 638. Why? Why is it not giving me? Do I have to go this way? There it is. Unable to mate selected entities. Why? That don't make no flippin' sense. I don't. Why? Okay, why are you gonna make a part that you can't manipulate? That's just dumb. Let me open this again. I may have to do a little modification to it. Can I guess, let's break the link. Yes. There we go. Let's see what that does, because maybe that was tying it down to where I couldn't. Nope, same fucking thing. Why they do this? They made it as, this is so silly. Let's do this. Attempt to heal all. Sometimes this. Save that. Let's try it again. Kind of annoying. There we go. That's what it was. Oh, flip it around. There we go. And then that's gonna be, it's gonna be literally smashed into there. So that's gonna be just like that. Alright, now I need to do that, what, 600 more times or something here? Oh my god. Probably need more than that, but that's a good start. Yeah, this is the tedious part, guys and gals. One, two, three, four. Oh, wait. Those two are, yep, those two don't count. Those are for something else. 1, 2, 3, 4, 5. So 5 more. 2, 3, 4, and 5. Oh, goodness. And that really slows me down. Hold this pause and make sure you don't need to flip it. I don't like that feature. You can probably turn it off, but whatever. We'll see how it goes. Hopefully there's an ASMR feel to this. Just watching somebody do the same repetitious act over and over again. I don't know if that'd be considered ASMR or if it'd be just rather freaking annoying. To each their own, right? There we go. Alright, those are done. Then, let's go. That's not going to give me. What's the dimension on that? That's 1/8 of an inch. That should be fine. It's pretty freaking awesome, actually. Okay. Let's go with. I'll have to double check that. I may have to get in the taller ones. This 1/8 of an inch, that's not very much clearance for any of the mounting brackets that they have for your cooling towers or cooling heat sinks and fans. I'll have to double check that. I'll have to look at because I think it said on that PDF that I had. I'll have to pull that back up. I don't even know where it's at. We'll save this as what the hell is this called again? Motherboard, PSU body mount, MB, whoops, oh my lord, PSU body mount assembly. That means I'll have to change the assembly in the other window. Alright, now we go back to our nuts. Self-clenching, those are microstand. I don't want to stand, I need nuts. Tell you what, designing holes and for captive screws and for a molded lid, that was crazy. That was really freaking nuts. CLS, I think that's what I need. Yeah. I want through hole nuts. There we go. CLA. No, I don't need ultra thin sheets. Self-clenching type. Forget what's the difference between CLA and CLSS is. I don't have one of their big, huge catalogs where I can verify. Oh, this cat. Sorry, guys. That's twice you guys seen my old lady cat. Type CLA. Used in steel image sheets. 50 or less. 82 or less. Inch. Oh, okay. They have that serrated. Okay, yeah, we'll do that. 832s. Those there. And the shank, let's do. Let's see, I'm doing. Oof. I'm gonna have to get the. Oh. Yeah, that's fine. Get the big one. Grab the CAD. Download. go into the folder. Cut that. And we'll move it in our design folder. Components, pin. This is the CLA version. Folder CLA. Change the part. And go back to SolidWorks. Drag and drop. And we'll open. Whoa, 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 whoa. Why did it do that? Ah, son of a bitch. That's not what I wanted it to do. It made it a derived part. I don't understand why it did that. Alright, let's open up a new drawing then. New part. Move that in there. No. There it is. We'll break the link. Then we'll do the diagnostic, heal. Beautiful. Save Ola. And then we'll go back to here and bring those two in. I'm going to need two of those bad boys, if you please. Let's see. I believe that's my shank. 0.05. Oh, shank is from here to here. Okay. Whoops. That should be the 0. Yep. Okay. That's what I want. Okay. Gotta make sure I know what I'm doing here. And we'll flip that. This goes to here. Press fit and singed. That's how we want it. Come on. These just bad boys just make assembly go really fast whenever you don't have to hold a nut in a wash or anything. You just rock and roll it. Alright, that part is done. Now I need to import this and replace the one that's in the shell assembly. Cross our fingers and make sure that's going to work right. Replace item, replace component with body mount assembly. Attach. All that should. Okay. Let's look at the mates here and see which ones. That don't make no sense. Okay. Let's see, what is that? Why is there an issue? Now there's no error. Really? I don't understand sometimes. It's so weird. But they're in there. Now, let's verify. Let's see where the... Okay. wrong with all this? Edit. Missing the face. What face is it missing here? What the hell? Undo that. Oh, it's missing the plane. Okay. Let's go back. I don't know why. That's just dumb. The part didn't fucking change. So stupid. Why is it moving? Fuck it. So fucking annoying. That I can delete. That doesn't have anything to do. It'd be nice if you told me what. Oh my goodness. This is so dumb. It's right fucking there. Missing the plane. That should be. The plane didn't move. I don't understand this goddamn program sometimes. It's so stupid. Just go one part deeper and you found it. There. Was that hard? No. For as expensive as this software is, sometimes I get a little freaking annoyed. Alright, now why in the hell did this thing move? That don't make any sense whatsoever. Maybe it was never locked in place? I didn't pay attention. Can we do this? And I wonder if we can center it in there. Let's see here. What is this? Okay. Can we do... That's that plane, that's that plane. Oh, the board. The motherboard isn't... What's wrong with the mother... Oh, yeah. I knew that. Shh, shh, shh. Okay, now that's locked in place. Alright, now... Let's get the... motherboard. Let's see if we can line that up with the PSU. There it is. What does that do? I didn't select anything. Oh my god. What's the distance on that right now? That's back. Let's go 1.25 and see what that... Oh yeah, I like that. Okay, we're good there. Alright, now that's locked in place. That's good there. I don't know if the 1/8 of an inch is going to be enough. I really think I need the taller ones. Those were the SOAs, I believe. Nope, these are nuts still. Standoffs. There they are. Let's verify SOAs, yeah. Boom. Okay, those can go away now. That's a 4. I can't remember what those were for. Yeah. And 632s. And the length. Let's see, I did these ones before, I think? No, I did the... Oh, no preference. I got the -8s, I believe. So I think I want to double that and get the -16s. No, I don't want zinc plated. I want aluminum. Thank you. So why is it... I'm confused. The length... Is that the thread length? They don't have a very good... It's been so long since I've messed with these. If I have 1/8 of an inch thick and length is... So 375 should work and give me 1/4 of an inch clearance. If I do a 1/2 inch, I still want to know what H is. I don't understand what that is. No, that didn't help me none. Oh, don't do this. Stop. Off here. What the there we go. 0.4375. I think that's the right one. You know, let's look at that. Bring this over here so you guys can see what I'm looking at. That's there. 375 is from the... So what's the... So this must be H. Oh, H is for X, not height. L is the length from... Okay, alright. Now I understand. Thread depth is 0.188, 187. Yeah, got it. Overall is 0.375. Okay, now I understand. So 375 minus 120. 375 minus 125 should be 0.25. Yeah, 0.25. And that's what I want is the 0.25. Okay, so this is the one I want. Okay. Good Lord have mercy. That was too painful. It's a good thing I double checked that because it just did not look right to me. Oh no, I want not CLA, SLA. Paste. Change the... Come on. Change the naming convention. Get out of that. Oh, I've got so much open. Do a new part. Drag and drop. No. And get rid of that. Save that. Yep. Break the link. Import diagnostics. Heal them. Good. Save. And let's go back to here. And we should be able to just swap those out. That should be All instances with the -12. Boom, and I should be able to do all the reference space suppressed and valid or no off. Jesus, really? I gotta do every single one it can't figure out by itself. I gotta figure out where the next one is. Jeez, where is it? They really need to make this a little bit. Okay, I think that's it. That one's got the blue on it. Nope, they all do. You know, it don't really matter. Okay, I guess it does matter. Okay, let's just get out of that. So annoying. Come on, you can do better than this, SolidWorks. Yes, replace all. And this one, I should be able to do that. Edit that. Oh, stop it. There we go. Yes. Refresh that, and we're still having issues. Nothing. Guess it didn't want to update. See, it should be smart enough to do all that by itself. I shouldn't have to hold its hand all the time, because that's really annoying. Let's go ahead and save that. Go into here, and so now we're freaking out again. Oh, I know why. Yep. Let's move that up, then we can fix that. Same reason. I can't find you. Alright, yep. Alright, there we go. Close. Fits. Shrink all these down because craziness. And all that's in place. Missing that. Why is that not? Oh, son of a bitch, I picked the wrong goddamn mate. God damn it. Fuck. Ah. Tell me which one it is. To be this here. Hello? Fuck. Yeah. I gotta do that to every single goddamn one of them. Wish there was a way to do this faster, but I'm sorry, guys. There isn't a way. This happens when you go too fast. So annoying. Oh my god, really? That's that one. Next one. This one. Oh, that was a little faster. I'm sorry, where are you? Why is it showing up? Yes. Oh, oops, screwed that up. Two more. Yeah, cool. Oh, that was painful. Yeah, let's close out some of this shit that I don't need here. All that just so I can go. Let's get rid of these. I don't need any of this stuff anymore. Okay, that took a little longer than I wanted to. Where are we at here? Alright, got that where I want it. Now, the bigger ATX would have to go a little bit in, which we can do that next episode. What I really want to do. Oh, that's the thing I need to look at. Okay. Let's see. Where is that? Alright, what I need is the, where's the top view here? Oh, I'm not seeing those. Oh, here we go. ATX port all views. Where is, that's not what I want. I want this one. Oh, goodness gracious. Okay. So we've got to keep out of 1.5, keep out of 3. Now, if this is the area where the board goes, Jesus, the CPU goes, then I'm definitely wanting to stay away from there. And if we look here, we've got to keep out of 1.5, keep out of 0.6. So if I have a 2-inch standoff, now the one trick is going to be, is can I make this large enough to set that on, because we're going at least 1/4 of an inch to match the 1/4 of an inch from the center of this hole to the edge. My next plate to mount on top of this is going to have to be pretty much the same. And we have, for this one, we have, what is that, 9 inches? 12 inches. Let's look at this here. The orientation. So it's going to pull in cool air and expel hot air that way. Honestly, yeah, that's going to be, I can't do it that way. So really this needs to flip around as well, so it's pulling from this side. Oh, so it's going to have to be mounted on over here. But I can't go, let's see here. If I put, oh, that's right, I got to go into, alright, let's get all of this shrunk down. I got to go into, where is it? There it is. No. That's the one I need. Alright, if I bring this down, I thought I gave it, I did. Okay, let's bring it down as far as it'll go. Then I can look in here and see what my height above here is. So I need to go, what is this going to be? There. Just a hair over 6 inches. And that is, more than 4. Oh, ooh. So if that's all the way down, 5.5, it'll be 5 inches. If I do a 2-inch, oh, plus the thickness of the plate, which will probably be 1/8 of an inch PVC or something like that. Then that gives me about a 3/4 of an inch clearance between the bottom of the GPUs and the top of this in this orientation. If I flip it, I don't think I have enough room there. So I need to stay in between there and there. This was what, 3 inches? Is that right? 2.85. Okay, we'll have to look at that. 2.85. Let's see, where will the cold air intake be? Ah, you have not watched the other ones. Basically, I can go over this real quick. This is an air intake plus filter. And the gist of it is that it'll pull in ambient air through here, pass it through a filter, and then it'll blow it up through. That is if I verify how this operates. I believe this is how it goes. I'm not 100% sure. I'd have to get one in and take it apart. But if it does what I think it does, and I'm pretty sure it does, it has 270 degrees around where it pulls in air and then pushes out the back 360 minus 270, whatever that is. And then this is a dehumidifier. Basically, it's got like an absorbent silicone gel pack, so it'll suck moisture as it's passing through. And then it'll come up through here, and then it'll circulate, basically just fill the void. And then I have a 3-inch exhaust fan that's pulling like 3 times more, so it'll create a vacuum in there. I'm not 100% sure if this is going to work right, but there'll be plenty of airflow for as small as this container is going to be. But that's the gist. Intake comes in through the bottom, flows through here, and then gets sucked up out of here while the fans push and move it around and all that other good stuff. So let's make a bracket. Not a bracket. So we're going to do, let's see, CPU should be over here. And usually they have the, this is going to be tricky. Because all I need to do is just clamp mount that, basically. That's super cool. Well, thank you. We'll see. I mean, this is pretty much off-the-shelf components and some custom stuff that we'll have to actually see if it works. Let me free float this and see how this looks. Mates in here. Let's get this out. Delete those mates. And I'm going to pull this and I'm going to rotate it. And I think I want it going this way. If I do it this way, then it's going to force the air. It's actually going to blow hot air on the cold side. So I don't want to do that. I want it to intake the cold air and push. That means I'm not getting a lot of cold air through the system. That disturbs my calm. Let's do this. Let's go. We'll go, yeah, let's do 2 inches off. No, 2.125 because I'll have a 2-inch standoff plus the thickness. Alright. And let's see if we can move this. That's not going to work. Oh, it's angled, that's why. Let's run that parallel for just a second, just so I can see what's going on. How much room do we have here? Honestly, I need this. Man, that's so close. Too bad those things don't have actual mounting brackets. So what we'll probably have to do is basically have a small strip of plastic that mounts 2 inches above here with 2-inch standoffs, and basically you just zip strip it to that strap. I do not like that idea. I don't like that idea at all. All right, let's do this. Let's go ahead and delete these. And let's go like this. Let's put this 2.125 up, and we'll make this actually, let's put that in. Let's see, I need a 1/2 inch clearance on each side for the standoff. Not each side, but total. So 0.5. So let's do 0.875. Which should give me enough. Oh, I want this. There we go. Ooh. That still gives me in between. Let's see. Can I get? I can't get that. Let's get the center of this to this edge. Now that's assuming that most of the form factors are like this. This might be a little hard to. Might be a little hard. Let's see. That is not what I want to see. An inch on the diagonal. Oh, excuse me. My apologies. So probably close to 3/4 of an inch. Which is pretty close to what I want that for. So, and that runs the length. Okay, that's all fine and dandy for this, but what about an ITX? Or an not ITX, Jesus. Oops, micro ATX. Oh, that's still fine. Oh shit, that works out a lot better than I thought it would. So I can actually, let's make those edges up. And let's put that back on the ATX. Oh, that's, well, that's slicker than snot. Okay, that's actually not bad. Now, the only thing I don't like about this design is that there's not really a way to secure this. Unless I do some kind of a funky something or other. Alright, let's isolate these items. Okay, bud. Isolate. I'm gonna look at a top-down view of that. Yeah, that's damn near right down the middle. So if I can go, yeah. I don't know if I can put this. Oh, yeah. That would actually be pretty boss. Okay, yep. And this will probably wrap up this episode once I get this little part that I'm going to do for you guys. Let's do this. New part. And I'm going to verify the size here real quick. 0.25 that way, and I guess I can do 0.25 off of there. So it's 0.5. 6.2, so I want 6.7. Let me write that down so I don't forget. 6.70 by, now this I think is 0.4. No, that's 0.25 as well. Okay. I don't know why I thought that then. That's 2.85. 2.85 plus 0.5 is 3.35. So 6.70 by 3.35. Oh, wait. Is this... Yeah, that's square. Okay. And rectangle. And it's 2.35 by 0.70. And I'm going to extrude that by 1/8 of an inch. And that's going to be a plastic. Nope, no, I don't want to configure. I want to edit. Plastic, plastic, plastic. Non-metals. Oh, plastics. Here we go. Yeah, ABS is fine. Should be anyway. Probably need it black, but whatever. So this will be the server PSU mount. And we're going to do... Oops. Ooh. Do some holes. And 632. It'll have to be a slip fit. No. I need clearance. Here we go. Screw clearances. Number 6. Through all position, top. One on each of these corners. Seriously? Why? Get it. Intersection. Intersection. That, and then I want to do a slotted fitting. To where I can have a couple of different thicknesses. So let's do this. Let's do a sketch here. We'll do another rectangle. But that's going to be for construction. And that can... Yes, that can do that. And then I need to find... What's the thickness on this? Real quick, I forget. 1.5 inches. Okay. For now, That'll be my minimum thickness. Let's do... Yeah, 1.5 should be fine. Nope. That's just a guideline. Alright. From there, use that as my guideline. And I think I can do a slot in here. I just need a regular slot, people. Yeah, slot. That's what I want. Okay. And we can make that... why not? If I do this, what I'll want is just a bracket. Actually, this will be threaded. No, you can't have a threaded slot. So it'll be basically a nut and bolt thing. That'll be fine. Uh, 632 should be fine. Slight length. That's what I need to figure out here. I need the orientation to go a different way. How can I do that? Can I change the orientation? Now let's see what happens here. Two, three, four. Okay. Yeah, I can do it that way. So these will be vertical. And I want the center of that slot to be like right about there. So let's do a center line, vertical infinite length, right on that bad boy. And then this, and this will be symmetric. And then we'll also do center line horizontal infinite length. And this, and this will be symmetric as well. So I should be able to do, oh, whoops, I forgot. That needs to be symmetric with that. So if I change that, all four will change dynamically. Okay, good. So, how do I want to do this? I want it to be pretty close. Let's go with 5. Yeah, I like that. And you know what? Let's make that a little bit bigger. Let's go with 3/4 of an inch. And we'll put this bad boy right on the edge. That's pretty goddamn good there. And we can hide this. Whoa, that's not what I wanted. And because I hate sharp corners, we're gonna chamfer that off a little bit there. I do not like sharp corners. Yes, it adds a little bit of cost, but for me it looks so much nicer. Alright, I'm good with that. We'll save that, and then we're going to put that in there. Oh, that's not what I want. Shit. Let's try that again. I don't need another one of them motherfuckers in here. Alright. Now, if we do this right. Yeah, you know, because I'm going to have to realign this on this once I get this in place. Okay. So, we're going to put that in. And do this in here. And I'll have to go grab some inserts, but that's fine for now. This will go mate to this guy. And I want to take that mate, not that one, that one. I want to take that mate off. That way, I can mate it with this bad boy. Where are we here? There it is. Yep. And, yep, center that. Oh. That's not what I was expecting. What the hell just happened here? Did I screw up? Oh, I don't have a center. Okay. Alright, well, we'll fix that. We'll just grab this point. And do that. There we go. Should work. Yes. Yep, there it is. Boom. In place. Now, all I need is some 1/2 inch by 1/2 inch thick aluminum, or I would rather use aluminum. Some aluminum angle with some holes in it, and then basically you just squish it up there and you're good to go. Yeah, I'm digging it. And I actually have some aluminum down in the basement, so that's where we'll leave off for tonight, for this episode. And what I'll do is grab that angle iron and get some dimensions off of it, since I have some already. And we'll put that in there with the holes in place. And then mount it to there, and I'll also get the standoffs that I need. Yeah, get the standoffs I need for that. Be male to female, 632. And I don't care. Well, I'll get them aluminum, but you can get them like powder coated aluminum black and shit like that. But those get expensive like that. So that'll be the next step. Get that finished off. And we are so close to that. Look at that. What is that clearance? What is that clearance, Clarence? Just a little over 1/4 inch. Oh, that's nothing. I've had clearances of like 0.005 before, or some of the other shit I've had to do. Now, if I can get this to work, it's possible I might I might be able to reconfigure the size of the shell and shrink it down a little bit. Nah, not really. We're pretty close there. I really don't want to do that. Yeah, that's pretty smashing. I'm digging it. The only other thing I would need to make sure is find out if the motherboard is generally is in this area here. I believe so, because you're gonna have your, ooh, that's something I didn't think about. Yeah, I'm gonna have to look at some of the boards, ATXs, and see based on this orientation where the holes are. This one would be my dead giveaway, as I believe this is where your IO comes into play. And I really don't like the way that fan is, because that's supposed to be sucking in cold air. I may have to do that 180 to where the fan is pulling air from through here and then blowing it out. It'll go back this way. Yeah, I may have to change the orientation on that because it's not meshing with what I'm thinking. And I really hate this, the way that looks. Huh. I honestly could put like 40 or 30 millimeter fans in these. Maybe. I don't know. Some afterthoughts. All right, moving along. Kind of craziness. All right, I think that's it for tonight. I appreciate everybody swinging by and checking it out and all that good stuff. So I'll be here next week, same time. And it looks like we're getting pretty close to wrapping up the initial design, uh, so that I'll be ready to go with some prototyping once I can do stuff like that. So I mean, would not be that hard to do. So anyway, thanks again. It was a treat. This is a fun little, well, minus a couple of the goof ups, but yeah, this was good. It was a lot of fun. I appreciate y'all coming by. And that'll be it for tonight. Thank you so much. See you later.